Assalamualaikum warahmatullahi wabarakatuh and very good day to everyone. So we have now in the last subtopic in chapter partial derivative. So we have 7 subtopic. Okay, so before this we have seen in the video about the direction derivative. Okay, and then we seen about the chain rule. Okay, the formula, the chain rule, the formula to use when you want to do implicit differentiation when it's involved the function of two variables. And we also learn on how to determine or how to write the equation of tangent plane. Okay, the tangent plane to the surface. And now in the last subtopic we will see about the maxima and minima of a function of two variables. Okay, so if you can remember, previously I think in your school or in your diploma level, we have learned about how differentiation can help us on finding the critical point. Okay, if you can remember, I think in maths modern or in maths, we learn about the first derivative and the second derivative in finding the critical point, and the second derivative is used to evaluate either our critical point is maximum or minimum point. Okay, so it's actually the same concept here in finding the maxima and minima of a function of two variables, but because of it involves two variables, then we use the partial derivative, but the concept is still the same. We will do a first differentiation to find the critical point, where we will let the first derivative of our function to be equal to 0, and then we will find the x and y, the point x and y, so that one will be a critical point. And then for us to decide whether our critical point is maximum or minimum point, we need to perform a second derivative. So if it's greater than 0, then it will be maximum. If it's less than 0, it will be minimum. Okay, so the concept is the same, but because of it's involved the function of two variables, then it needs to be used to be done by using a partial derivative. Okay, so let's see first the extrema. What is the meaning of the extrema? So there are many practical situations in which it is necessary or useful for us to know the largest and smallest value of a function of two variables and its location. So we know that the function is actually represented a physical system. Sometimes the physical system around us, for example, a growth of a cancer cell, pertumbuhan sel kanser. For example, the halaju kereta, semua tu kita boleh modelkan dia dengan menggunakan differential equation, which is the equation, the function yang mewakili that system, those system. Okay, so sometimes kita perlu tahu kat mana maximum and minimum point dia. Where is the maximum and minimum value of our function? We need to know maximum and minimum value of our function. So for instance, if Txy is the temperature at point xy. Okay, for example, kalau Txy ni adalah function yang mewakili temperature pada point x and y on a square metal plate, okay, di atas satu kepingan besi berbentuk empat segi. Okay, then we are interested to know the hottest and coldest point on the plate together with their extreme temperature. So kita nak tahu, okay, pada certain waktu, pada certain point xy, kita nak tahu the hottest and the coldest point. Dekat mana di atas kepingan besi tu yang paling panas dengan yang paling sejuk. So kalau dia paling panas, berapa nilai dia? Okay, with their extreme temperature, berapa nilai temperature dia? So sometimes it's actually valuable for us to know those informations. Okay, so intuitively we can think of relative extrema as a high point or low point on the surface defined by z, f, x, function of x and y. Okay, so secara conclusionnya kita boleh anggap yang relative extrema ini adalah sama ada the high point ataupun the lowest point on the surface yang defined by, yang diwakili oleh function f in term of x and y. So if you can see in this figure, this one is the maximum. Okay, and then this one is the minimum. So we have absolute maximum, absolute minimum, relative maximum and relative minimum. But in our case, we will only see about the relative extrema, iaitu relative minimum and relative maximum. Okay, so let's see a few definition here. A function fx y, a function in term of x and y, is said to have a relative maximum at point AB if fxy is less than fab. Okay, so function in term of xy tu kita cakap dia mempunyai relative maximum pada point AB kalau function xy, maksudnya kita substitute x and y in the function. Okay, the value of x and y in the function is less than, we substitute the value of point A and B. So dia relative maximum. Kalau relative minimum, bila substitute nilai xy lagi besar daripada substitute nilai AB. Okay, so xy and AB is different point. So kita nak cakap relative maximum at point AB bila AB lagi besar daripada xy, ataupun xy lebih kecil daripada AB. Kalau kita nak cakap minimum, xy lagi besar daripada AB atau AB lagi kecil daripada xy. Okay, so nanti kita tengok. So untuk absolute maximum pula, so kalau yang ini relative maximum dengan relative minimum ni adalah pada point AB. Tapi kalau absolute maximum dengan absolute minimum, dia adalah benda yang sama, tapi dia pada domain, keseluruhan domain of f. Maksudnya for all value of x. Okay, pada all value of x, bila dia memenuhi function ini, dia adalah absolute maximum. Kalau pada all domain of f, pada all value of x, okay, domain ni value of x, okay, kalau dia memenuhi this relationship, means that dia adalah absolute minimum. Alright, so let's see the theorem here. If f has a relative extremum, so relative extremum you need to remember ada dua, sama ada relative minimum atau relative maximum. So relative extremum ni dia mewakili dua-dua, minimum dan maximum. So if f has a relative extremum at point AB, and if the first order derivative of f exists at this point, then fx equal to 0 and fy equal to 0. So if you can see here, this one is the partial derivative with respect to x, and this one is the partial derivative with respect to y. So how to find the point? Okay, dia kata kalau f ada point relative maximum ataupun minimum at AB, okay, kita nak cari point tu, kita kena let the first derivative equal to 0 and the first derivative with respect to x equal to 0 and also first derivative with respect to y equal to 0. Then kita akan dapat critical point. Kita panggil dia critical point. Okay, a point AB in the domain of fxy is called a critical point. So the point tu dia called critical point. Nak cari dia, kita kena cari dulu the partial derivative in term of x, partial derivative with respect to y, kita equalkan dia to 0 and then kita akan dapat point. So point itu adalah point critical, kita panggil critical point. Okay, so tengok example. Find the critical point for the function fx equal to x square plus y square minus 4x plus 6y plus 7. Okay, so what you need to do first is to find both partial derivative. So we need to find the partial derivative with respect to x, and also we need to find the partial derivative with respect to y. So partial derivative with respect to x means that we want to differentiate with respect to x. So y will be a constant. So this one will be kosong. This one also kosong. This one also kosong because semua constant. Okay, so now we just need to differentiate x square. We will get 2x. And differentiate minus 4x, we will get minus 4. So you get lah the partial derivative with respect to x is 2x minus 4. So when you want to differentiate with respect to y pula, x pula akan jadi constant. So you want to find the partial derivative with respect to y. So x ini constant, this one is also constant, this one also constant. So semua akan jadi kosong. So differentiate y square, you will get 2y plus with 6. Okay, so you get your partial derivative. So for us to find the critical point, we need to let our partial derivative to be equal to 0. So you ambil 2x minus 4 equal to 0. So you have 2x equal to 4. So your x is equal to 2. And same goes to y. So 2y plus 6 equal to 0. So 2y equal to negative 6. So y equal to -3. So now this one, 2 and -3 is your critical point. Okay, so it's easy actually. We just need to find the partial derivative. It's actually the same concept before, but only because of this one is involve partial derivative, so dia ada dua kerja lah. Kita kena cari the derivative with respect to x and then the derivative with respect to y. Okay, so we differentiate once, okay, and let all of them to be equal to 0, then we will get the point x and y. So that point is a critical point. Okay, and then after we get the critical point, we will go to the second partial test. So actually the second partial test is just for us to find either our value, our critical point is maximum or minimum. Okay, so if you see here, in order to identify whether a critical point will give a relative maximum or relative minimum or a saddle point. Saddle point means that you cannot decide whether it's a minimum or maximum. Okay, the second derivative test theorem can be applied. So what is the second derivative test theorem? Okay, so the second derivative test theorem, let f be a function of two variables with continuous second order partial derivative in some discenter at a critical point AB. Okay, so you tak payah tengok yang ini adalah dia punya derivation of dia punya formula. So you just need to see the formula. You need to find the value of D, di mana D adalah fxx darab dengan fyy tolak dengan fxy kuasa 2. So apa dia fxx? Fxx adalah derivatif kali kedua with respect to x. Kali pertama kita dah cari with respect to x, and then kita differentiate lagi sekali with respect to x. So dapat fxx. Apa dia fyy? Fyy adalah kali pertama differentiate with respect to y, and then kali kedua kita differentiate lagi with respect to y. So fyy. Apa dia fxy? Kali pertama awak differentiate with respect to x, kali kedua awak differentiate with respect to y. So you will get fxy. Okay, so you cari tiga value ni, and then masuk ke dalam formula fxx darab fyy tolak dengan fxy kuasa 2, kita akan dapat nilai D. And then kita akan check sama ada kita punya point tu minimum atau maximum mengikut kepada condition ni. Kalau nilai D yang kita dapat besar daripada kosong, okay, ada dua condition. Dia akan bagi relative maximum atau relative minimum. Kalau D yang kita dapat besar daripada kosong, tetapi fxx besar daripada kosong, besar dan besar. Okay, D besar pada kosong, fxx besar pada kosong, relative minimum. D besar daripada kosong, fxx kurang daripada kosong, relative maximum. Kalau besar-besar minimum, kalau besar kecil maksimum. Okay, kalau D kurang daripada kosong, so dia kata kita hanya ada saddle point. Dia bukan maximum, dia bukan minimum, dia adalah saddle point. Not maximum, not minimum. Kalau nilai D yang kita cari ni kurang daripada kosong. Kalau nilai D yang kita cari ni besar daripada kosong, kita kena tengok dua value ni, fxx. Sama ada dia besar atau kecil. Kalau dia besar, minimum. Kalau dia kecil, maximum. Kalau D kurang daripada kosong, terus that point, the critical point is a saddle point. Kalau D sama dengan kosong, there is no conclusion. Okay, so kita kena tengok value. So macam nak ingat? Okay, D dia boleh jadi besar daripada kosong, kecil daripada kosong, sama dengan kosong. Kalau sama dengan kosong, no conclusion. Kalau kecil daripada kosong, saddle point. Dia bukan maksimum, dia bukan minimum, tapi dia saddle point. Kalau D kita besar daripada kosong, kita kena check. Kalau fxx kita besar daripada kosong, point kita minimum. Kalau fxx kita kurang daripada kosong, point kita adalah maksimum. So ini adalah dia punya condition. So let's see this point, this question. Okay, determine the relative extrema of the function. So when question asks us to find the relative extrema, means we cannot conclude yet. Either we have a relative minimum or relative maximum. So we need to find out either kita punya function ni ada relative minimum ke relative maximum. So nak find out, first kita kena cari critical point. So nak cari critical point, first kita kena buat adalah kita kena differentiate sekali, partially with respect to x, with respect to y. So first kita buat with respect to x. When we differentiate with respect to x, so y will be a constant. So ini kosong, ini pun kosong. So just need to differentiate this one. Negative 3x square dapat negative 6x. Negative 6x dapat negative 6. So this one is your fx. Now we want to find fy, the partial derivative with respect to y. So x ni akan jadi constant, ini pun constant, ini pun constant, semua kosong. We just need to differentiate this one. Differentiate negative y square dapat negative 2y. Differentiate positive 10y dapat positive 10. Okay, so dah dapat fx, dah dapat fy. Macam mana nak cari critical point? Samakan dia dengan kosong. So negative 6x tolak 6 sama dengan kosong. Okay, so negatif 6x sama dengan 6. So x sama dengan negatif 1. So yang ini negatif 2y tambah 10 sama dengan 0. So negatif 2y sama dengan negatif 10. So y sama dengan 5. So kita dapat negatif 1 dengan 5 ini adalah kita punya critical point. But not yet can we decide whether this point is maximum or minimum. So kita kena buat second partial test. So second partial test kita kena differentiate lagi sekali. So apa yang kita kena cari dalam second partial test? Kita kena cari fxx, kita kena cari fyy, dan kita kena cari fxy. So fx dah ada kat sini. Nak cari fxx, differentiate lagi sekali fx. So differentiate negative 6x, you will get negative 6. Differentiate this one, you will get 0. So fxx is negative 6. And then fyy. Okay, fy dah ada sekali. Differentiate lagi sekali with respect to y. So awak akan dapat fyy. So differentiate negative 2y, awak akan dapat negative 2. Differentiate 10, awak akan dapat 0. So fyy equal to negative 2. And then we want to find fxy. So guna fx. Tapi differentiate with respect to y. Kalau awak tengok sini, fx awak tak ada y. So bila tak ada y, yang ini pun constant, yang ini pun constant. Differentiate constant dapat kosong. So fxy is equal to 0. And then kita masukkan dalam formula, kita nak cari d. Formulanya adalah fxx darab dengan fyy tolak dengan fxy kuasa 2. So fxx kita adalah negatif 6. Okay, darab dengan fyy negatif 2. Tolak dengan fxy kosong kuasa 2. So awak dapat 12. So 12 ni nilai D. So D kita adalah 12. 12 ni besar daripada kosong. Bila besar daripada kosong, kita kena check second condition, fxx kita. Fxx kita besar atau kecil daripada kosong. So kalau awak tengok, awak punya fxx negatif 6. So negatif 6 ni kurang daripada kosong. Jadi bila fxx kurang daripada kosong, okay, so kita punya point itu adalah relative maximum. So the function f has a relative maximum at point negative 1,5. Negative 1,5 ni adalah critical point. Ataupun nak boleh cakap negative 1,5 is the relative maximum point of a function f. Okay, so kita dah cari critical point, baru kita boleh decide the maximum ataupun minimum dengan menggunakan second partial test. So let's see the second example here. Okay, locate and classify the critical point of a function fxy. 2x square minus 8x plus y square minus 8y plus 7. So the first thing you need to know or you need to do is to find the critical point. So to find the critical point, you need to find the partial derivative. Mula-mula kita cari fx. So fx differentiate kepada x. So this one will be 4x. This one will be negative 8. This one will be constant kosong, constant kosong, constant kosong. So 4x minus 8. And then kita differentiate pula with respect to y. So this one will be constant kosong. This one also constant kosong. This one differentiate dapat 2y. This one differentiate dapat negative 8. This one constant dapat kosong. So 2y minus 8. So nak cari critical point, kena ambil yang ini. 4x minus 8 equal to 0. So 4x equal to 8. So x equal to 2. Okay. 2y minus 8 equal to 0. 2y equal to 8. So y equal to 4. So 2 and 4 ni adalah kita punya critical point. So we cannot decide yet either this one is maximum or minimum. We need to do a second partial test. Okay, so second partial test, benda yang awak kena cari adalah fxx, fyy dan fxy. So kita dah ada fx, differentiate sahaja lagi sekali with respect to x. So this one differentiate with respect to x, you will get 4. This one constant, kosong lah. So fxx equal to 4. So fyy, kita dah ada fy, differentiate lagi sekali with respect to y. So this one you will get 2 and this one you will get 0. So fyy equal to 2. Okay, now fxy. So differentiate your fx with respect to y. So sekarang kalau awak tengok fx awak tak ada y. Bila tak ada y, kita nak differentiate with respect to y. Confirm lah ini constant akan memberi jawapan sama dengan kosong. So sekarang kita nak cari nilai D. D kita adalah fxx 4 darab dengan fyy 2 tolak dengan fxy kuasa 2. So awak dapat sama dengan lah 8. So sekarang kalau awak tengok D awak sama dengan 8, dia besar daripada kosong. Bila dia besar daripada kosong, kita kena tengok value yang kedua, iaitu value fxx. So value fxx dia adalah 4 pun besar daripada kosong. Jadi bila D besar daripada kosong, fxx besar daripada kosong. Okay, D besar kosong, fxx besar kosong, kita punya titik itu adalah relative minimum. So titik critical point kita tadi tu adalah relative minimum point. That's how we decide on the features of our critical point by using the second derivative. Cumanya bezanya ini ada partial derivative. Okay, so dia ada formula dia lah. Kalau kita yang sebelum ni kita differentiate macam biasa, sekali je. Differentiate sekali equalkan to 0, dapat critical point. Differentiate kali kedua, tengok dia greater or less than 0, then it will be maximum or minimum. Tapi bila partial derivative, dia lain sedikit. Okay, let's see the last example here. Okay, so let's see the last example here. Locate and classify the critical point of fxy for the function fxy, x cubed minus 3x square, x cubed minus 3xy plus y cubed. So kita kena cari dulu critical point. Nak cari critical point, kita kena let equal to 0. Okay, kita kena cari partial derivative. So kita cari partial derivative fx. Okay, differentiate with respect to x. This one you will get 3x square. This one differentiate with respect to x, you will get 3y. This one constant, so kosong lah. So you get 3x square minus 3y. And then fy, okay, you differentiate this one with respect to y, kosong. This one with respect to y, you will get 3x. And this one with respect to y, you will get 3y square. Okay, so sekarang ni kita nak let dia equal to 0. So kalau you tengok, kita let 3x square minus 3y equal to 0. Also this one kita let 3x plus 3y square equal to 0. Kita tak boleh solve. Kerana dalam kedua-dua function ni dia ada x dan y. So apa yang kita kena buat adalah kita kena buat persamaan serentak. Nak cari nilai x dan y. So nak buat persamaan serentak. Okay, kita jadikan y sebagai subjek. So kita ada 3y sama dengan 3x square. So y sama dengan x square. Okay, 3 ni pindah sebelah. So y sama dengan x square. So y sama dengan x square ni, awak ganti dekat y kat sini. So 3x tambah 3, y sama dengan x square. Square sama dengan kosong. So kita ada 3x tambah 3x kuasa 4 sama dengan kosong. So you get x tambah x kuasa 4 sama dengan kosong. Keluarkan x. So you have x plus, you have 1 plus x kuasa 3 sama dengan kosong. So you get two value, x equal to 0 and x equal to 1. Okay, so awak dapat dua value, x equal to 0, x equal to 1. So kita kena cari dua lah juga value y. So y sama dengan x square. When x equal to 0, y pun equal to 0 lah. 0 square 0. So when x equal to 1, y pun equal to 1. Sebab y sama dengan x square. So x kuasa 1, 1 kuasa 2, 1. So kita ada dua critical point. Kita ada x equal to 0, kita ada 1 point 0, 0. Another point is 1, 1. So ini dua-dua ni critical point. So kita kena check dua-dua punya condition. Buat satu-satu. Okay, next. Kita nak decide whether critical point kita ni minimum ke maximum. Dan dia tak semestinya sama. Dia tak boleh sama. Okay, takkan ada dua-dua maximum. Okay, tapi kita check lah. Okay, mana tahu tiba-tiba dua-dua maximum. Okay, kita tengok. So, kita kena cari nak cari maximum or minimum, kita kena buat second derivative. So kita kena cari fxx, kita kena cari fyy, kita kena cari fxy. So awak dah ada fx. So differentiate with respect to x lagi sekali. So awak akan dapat fxx awak adalah differentiate this one with respect to x, you get 6x. Differentiate this one with respect to x will be constant, so 0 lah. So fxy awak, fyy. Okay, fyy. Differentiate this one with respect to y, 0. Differentiate this one with respect to y, we'll get u6y. Okay, and then fxy. Differentiate fx with respect to y. So nak differentiate sekarang ni fx kita dah ada, nak differentiate dia with respect to y. So ini akan jadi constant, kosong. Yang ini akan dapat negative 3. Okay, and then because dekat sini ada x dengan y kan, so kita kena gantikan nilai x dengan y. So kita ada dua ni. Okay, so kita ada dua. Yang pertama, x dengan y equal to 0, 0. So bila x dengan y equal to 0, 0, fxx kita 6 kali kosong, kosong. Fyy 6 kali kosong, kosong. Fxy negative 3 lah. Okay, bila kita punya point 1, 1, oh ni salah ni, negative 3. Okay, negative 3. Bila kita punya point 1, 1, okay, so kita gantikanlah 6 darab 1, so fxx kita 6. 6 darab 1, so fyy kita 6. Dan kita punya fxy masih lagi negative 3. Okay, so kita dapat dua benda yang berbeza. Kena buat satu-satu. So kita kena cari D untuk yang kosong-kosong dulu. So untuk yang kosong-kosong, cari D guna formula fxx kosong darab dengan fyy kosong tolak dengan fxy kuasa 2. So dapat negatif 9. So bila D awak kurang daripada kosong, automatically the point here is the saddle point. Automatically kurang daripada kosong. Okay, and then kita buat pula untuk 1, 1. So fxx 6 darab dengan fyy dia 6 tolak dengan dia punya fxy kuasa 2. So 36 tolak 9, awak dapat dia sama dengan 25. Berapa? 36 tolak 9? 27. Okay. So awak dapat 27, 36 tolak 9, 27. So 27 ni greater than 0. So bila greater than 0, kita kena tengok fxx dia. Fxx dia 6. 6 pun greater than 0. So bila D greater than 0, fxx greater than 0. So kita punya point itu adalah relative minimum. So maksudnya point kita tadi ada 2. 0, 0 adalah saddle point. Dan 1, 1 adalah relative minimum point. So dia boleh jadi ada dua critical point tapi berbeza sifat. Satu tu saddle, satu tu minimum point. Okay, tapi dia punya conclusion dia nak check kita punya maxima and minima, iaitu relative extrema. Relative extrema tu boleh jadi dua, either relative minimum atau relative maximum. So the first step is to find the critical point. Find critical point, buat first derivative, okay, equalkan to 0, and then you will get the point x and y. That one is the critical point. Okay, and then to check the critical point either is maximum, minimum or saddle point, kita kena buat second derivative. So cari fxx, cari fyy, cari fxy, masuk dalam formula fxx darab fyy tolak fxy kuasa 2. Tengok dia punya D. Kalau D dia greater than 0, kita kena check fxx. Kalau D greater than 0, fxx greater than 0, point kita minimum. Kalau D greater than 0, fxx less than 0, relative maximum. Kalau D kurang daripada kosong, automatically saddle point. Kalau D equal to kosong, kita buat kata no conclusion. Tak tahu maksimum ke, minimum ke, saddle point ke, kita tak boleh conclude. Okay, so that one is the last subtopic in this chapter, which is the partial derivative. Thank you everyone. Assalamualaikum.